Ramanujan for G is now available on the Google Play Store. Try it out for free.
Good morning, class. So today, we'll first see one problem based on the just a minute. Let me. Yeah. So first, we'll look at one question, which is the distance between origin and tangents to a curve y is equals to e to the power 2x plus x square drawn at a point is equals to 0 is. So solving first, we'll put x is equals to 0 in the curve. We obtain y is equals to 1. So point is 0 comma 1. Next, y is equals to e to the power 2x plus x square dy by dx is equals to 2 e to the power 2x plus 2x. That means dy by dx 0 1 is equals to 2. So equation of tangent at 0 comma 1 is y minus 1 to x minus 0, that is 2x minus y plus 1 is equals to 0, right? So the required distance is equals to length of perpendicular from 0 comma 0, right? So that is 1 by root 5. So this is our answer. Okay, so copy this. We'll look at one more problem. First, you need to copy this problem, then we'll proceed. Okay. Next, one more problem. If P1 and P2 be length of perpendicular from origin on tangent and normal to the normal to the curve x power 2 by 3 plus y power 2 by 3 is equals to a to the power 2 by 3. Then 4p1 square plus p2 whole square equals. Options are 4a square, 2a square, a square, and none of these. None of these. Okay, so let's solve. So first we'll take the parametric equations. That means x is equals to a sine cube theta, y is equals to a cos cube theta. So tangent is x cos theta plus y sine theta is equals to a by 2 of sine 2 theta. Normal is y cos theta minus x sine theta is equals to a cos 2 theta. So P1 is equals to a by 2 sine 2 theta divided by under root of cos square theta plus sine square theta, which is equals a by 2 of sine 2 theta, right? Similarly, if we move for the P2 terms, a cos 2 theta cos square theta plus sine square theta, a cos 2 theta plus p square. So similarly, a square sine 2 theta plus of cos square 2 theta, right? So solving this is one, and you will get your answer as a square. So that means option number third is the correct option. So you need to copy. Okay, so next thing is angle of intersection of two curves. Okay, so first let's draw the curve diagram. Okay, let be a curve is this. This is the tangent. Another curve is this one, and this is the tangent for this. Let this angle be psi 2, this be psi 1. This point P is curve C2 and this curve C1. Okay. So the angle of intersection of two curves defined to be the angle between the tangents to the curve at their point of intersections, right? So let C1 C2 be two curves having equation y is equals to fx. Equation is y is equals to fx and y is equals to zx respectively, right? So let pt1 and pt2 be the tangents to the curves c1 and c2 respectively at their common point of intersection. So then angle theta between the pt1 and pt2 is the angle of intersection c1 and c2. C1 and c2, right? So psi1 and psi2 be the angles made by the pt1 and pt2 with the positive direction of the x-axis, which is in the anti-clockwise sense, right? Then what we can conclude, like m1 is equals to 10 psi1, which is slope of tangent to y, which is equals to fx at p, which is equals to dy by dx at c1. Similarly, m2 is equals to 10 psi2 is equals to slope of tangent to y. That means y is equals to gx. Y is equals to g of x at p is equals to dy by dx at c2. Right? At c2. Got it or not? So here we can see this phi is equals to psi1 minus psi2. That means 10 phi is equals to 10 of psi1 minus psi2. So 10 phi is equals to 10 phi minus 10 psi2, 1 plus 10 psi1, 10 psi2. That is 10 psi is equals to dy by dx c1 minus dy by dx c2 divided by 1 plus dy by dx c1 and dy by dx at C2, right? So this means the orthogonal angle between the tangents is 180 degree minus phi. So generally the smaller of the two angles is taken to be angle of intersection. So for the orthogonal curves, if the angle of intersection of the two curves is a right angle, then the two curves are said to be intersected at intersected of the orthogonal, and the curves are called the orthogonal curves, right? So here orthogonal equation we can write if the curves are orthogonal, then phi is equals to pi by 2. That means m1 m2 is equals to -1. So that is dy by dx c1 and dy by dx c2 is equals to -1. So this is the final answer. Okay, so copy this first. All three slides are important. Next slide. Okay, this orthogonal equation. Okay, so now let's look at examples. The angle of intersection between curves y is equals to x and y square is equals to 4x at 4 comma 4 at 4 comma 4. So solving, first we will differentiate outside. So dy by dx of 1 is equals to 1 and dy by dx is equals to 2 by y at 4 comma 4. Dy by dx 1 is equals to 1 and dy by dx 2 is equals to 2 by 4, which is half. So hence of angle of intersection will become tan inverse 1 minus 1 by 2, 1 plus 1 of half, which is tan inverse of 1 by 3. Okay, so this is our answer. Next question, the angle of intersection of the parabola y square is equals to 4x and x square is equals to 4ay at origin is. So option 1 is pi by 3, option 2 is pi by 2, and option 3 is pi by 4, and last of the option is none of these. Okay, so that means y square is equals to 4ax, that is 2y dy by dx is equals to 4a. So at 0 comma 0, dy by dx is infinity, which is equals to tan of pi by 2, and which is tan theta. Let's say it be tan theta. So theta 1 is equals to pi by 2. So again, x square is equals to 4ay 2x, that is a 4a dy by dx. So again, if we solve, dy by dx is x by 2a, and a at 0 comma 0, dy by dx is in 0. So tan of 0 is tan theta 2, let's say tan theta. So finally theta 2 is the 0. So again, between the two curves, theta 1 minus theta 2 is pi by 2. So this is our answer. Next problem. Angle between the curves y is equals to sin x and y is equals to cos x is, options are pi by 4, tan inverse root 2, tan inverse 2 root 2, and fourth is none of these. Okay, so here we can say x is equals to pi by 4, which is a common point, which is a common point. So that is sin x is equals to cos x, and that is tan x is equals to 1. So here x is equals to pi by 4 and y is equals to 1 by root 2. So for the first curve, dy by dx is cos x, which is 1 by root 2, where x is equals to pi by 4. For second curve, dy by dx is equals to minus of sin x, which is minus 1 by root 2. So solving, tan theta will become 1 by root 2 minus of minus 1 by root 2 divided by 1 plus 1 by root 2 and minus 1 by root 2. So solving, 2 by root 2, 1 minus 1 by root 2, and which is equals 2 by root 2 I half. So that is 2 root 2. So theta is tan inverse 2 root 2. So from here we can say this option third is the correct answer. Option 3 is the correct option, right? Okay, so you need to copy. Okay, so thank you guys. See you in the next class.